How's it going, everyone? Welcome back to another video on the channel. Now, the video that I have for you guys today is a rather interesting one because it's kind of an inflection point for the channel. Now, what do I mean by that? Well, if you've been following my videos and content closely over the past few years, you'll know that I've been really focused on producing videos for this guy right here. And for those that don't know, this is my C5 Corvette project car that I bought in 2018, sight unseen from a salvage insurance auction. The car was involved in a light front end accident, so it was totaled out at auction. So over the past few years, I've been working to fix it up, restore it, and also add some fun modifications to the car as well. Well, not only am I a big car enthusiast, I'm also a big enthusiast and have a huge hobby and passion for 3D printing. And actually, I'm fortunate enough that that is my full-time engineering job as well in the aerospace industry. But I also have, not just at work, but I have 3D printers at home here, and I 3D print a lot of different parts for the car and things around the house and other side projects. But moving forward, my goal and focus for this channel is to really hone in on how you can apply and use 3D printing in an automotive kind of environment or space. Now, I'll be also introducing other 3D printing projects as well, and also more car content as well, but that's really the overall goal for the channel, and it starts with this video. Now, over the past few years of largely producing videos on my C5 Corvette build, I have sprinkled in some 3D printing videos as well, and a few of those videos have revolved around 3D printing parts that have helped in the rebuild process for this car. And one of those videos was me designing and coming up with this 3D printed spacer kit when I was removing a damaged fender on this car and replacing it with a new fender. And the spacers helped me to set the correct gap for that fender so all your panel gaps look nice and clean. Don't mind the panel gap now, the car is actually on a battery tender, so the hood isn't fully closed. But when the hood's closed, the panel gaps actually look really nice on that side, on the side where I used the 3D printed spacer kit. So that was really the first project of heavily applying, I say heavily applying 3D printing to my C5 Corvette build, and my goal moving forward here is to only ramp that up even more. Now, observant viewers of the channel might have noticed that I changed the name of the channel a little over a month ago, and that is all related to kind of what I've been talking about just a little bit in this video, but I will be making a whole separate video on the meaning of the name of the channel, the focus of the channel moving forward, etc., etc. But in this video, the goal, like the title says, is to focus on getting serious about 3D printing car parts, and I'll go into detail on what that means here. And for those that also don't know, I actually have an Etsy store where it is intended to be my storefront for different types of products that I'll be selling. I currently have had 2 products on the Etsy store over the past few years, one of which is the digital blueprint kit for my go-kart project that I built years ago, and the other is that 3D printed spacer kit so that people can buy that kit that I build for doing the same type of repair on their C5 Corvette. I recently had to take the listing down temporarily because I had some changes to my family, but all good changes, so I had to take a little time away from fulfilling 3D printing parts orders, but I do plan on getting that listing back up online shortly, and it kind of all starts with this video. I know I've had a few people reach out and ask me about where those kits went and if I'll still be making those. So the answer to that is definitely yes, but I wanted to do the things in this video first, and I was also waiting on a few parts for my 3D printers because they were on back order. What do I actually mean by getting serious about 3D printing car parts? Well, that largely revolves around the material that I'll be using to 3D print the parts, not only just for my car, but also parts that I'll sell for people to install and use on their cars as well. And the material you use and choose to 3D print your parts with will greatly dictate the end part's performance on how well it does for different things in and around the car. Now, without going into too much detail, this will be a whole nother video on the channel probably, but in summary, there's only a select group of materials that you're going to print with desktop level 3D printers before you start having to invest tens of thousands of dollars into specialized 3D printers with all sorts of different features to print higher end materials. So there's really only, I'd say, probably 3 or 4 materials that you're going to print with. And the one that I've been printing with recently is something called PETG. And that material is mostly known for kind of single-use food packaging, most commonly like single-use water bottles or Coke bottles. Those are usually PETE. The E and the G are just modifiers to the polymer. whole nother wormhole, rabbit hole of a video, but that's one of the materials that you can print with on desktop printers. Now, I actually don't like that material. It's really difficult to print with, and its performance is okay. It's not great, and it's okay. And I have printed some parts for not just my car, but also my Tundra and things like that, and they've been outside and held up to the weather and environment pretty well. But moving forward, I think there's a better material choice that I'm going to focus on and really try and specialize in for all the parts I'll be making. The material that I've chosen to 3D print all of these car parts with moving forward is actually one of the lesser known 3D printing materials of the desktop level hobbyist kind of 3D printing materials. However, it is kind of like a nicer cousin to one of the most common materials that people print with, and that is ABS plastic, or acrylonitrile butadiene styrene. For those that aren't polymer wizards, that's the black pipe that you see in your common hardware stores like Home Depot and Lowe's, the black sewage pipe that people run in all sorts of different housing projects for drains and things like that. That's most commonly where you find ABS, but actually, believe it or not, a lot of the interior kind of trim and panel pieces that you find on the inside of your car are injection molded ABS parts as well, because that material is relatively cheap and pretty heat resistant as well. But ABS, when it comes to 3D printing, has its fair share of nuances, just like PETG, and that's where ASA comes into play as its nicer cousin, acrylonitrile styrene acrylate. Now, I'm not a polymer wizard, but I've done some research, and I think the acrylate additive to that polymer makes that plastic a lot more easy to print with. ABS commonly has problems with warping, layer delamination, cracking, things like that, and it's also not very UV resistant, which is important for cars that spend a lot of their time outside. Now, ASA actually is very UV resistant, so it's kind of gives you the best of both worlds, and it's supposed to be relatively easy to print with, and that's kind of the goal of this video, is to start printing with that material. Now, I just realized I said that a lot of interior pieces found in most cars are actually injection molded ABS, and then I went on saying that ABS is not really UV resistant. I'm going to correct myself and say that 3D printing ABS is not very UV resistant. I don't know what type of modifiers that maybe they add to the injection molding pellets to create interior pieces that make them hold up to the sun, because obviously, you know, dashboards and other things like that do get exposed to sunlight in cars and hot environments, and you don't want those fading and warping and cracking. So it's probably just a variation in the polymer or a modifier that gets added in. But most of the time, 3D printing ABS does not hold up well in the sun, so that's why it's important to print with ASA for anything that's going to live outside for an extended period of time. Now, one of my goals for 2024 is to keep my videos really concise and to the point, and I'm sure I lost a lot of you already because I kind of went into some nitty-gritty details on the material, but I wanted to just cover my bases in this video of why I'm choosing to 3D print car parts using this ASA material. Now, if I haven't lost you already, I'm going to try and not lose you now, but one of the other changes that I'm going to be implementing to my 3D printers here at home is actually changing the nozzle, so the size of extrusion bead that the printer lays down when it's printing the part. Normally you print with a 0.4 millimeter nozzle. I'm going to up to a 0.6 because that allows you to print larger parts a lot faster, which for the most part, car parts are most of the time larger, don't require a lot of fine feature resolution or definition. So that's going to be my goal, is to also tune in the settings for that larger nozzle on my printers. So the goal for this video today is I'm going to get that ASA material loaded up onto my printer here in this cabinet. I'm going to install that new 0.6 millimeter nozzle, and then we're going to run a kind of calibration test print to see how it turns out. Normally I do have two printers in this cabinet here. I've moved one over to this other setup I have going on here. I'm revamping this whole printing cabinet because I did just buy 2 more 3D printers to prep for printing all of these extra parts. So I'm building a whole nother enclosure. That's why I only got one here, but it'll give us a little extra space to work on this printer to replace that nozzle. Now, a quick tidbit that I want to harp on real quick is one of the most important things with 3D printing is to set your printers up in a consistent and stable environment. You want to avoid anywhere where there's drafts or rapid fluctuations in temperature, mostly cooling fluctuations from any type of draft, from an air conditioning vent, from an open window, or in my case, if I open the garage and a draft of cold air comes in, that's going to really negatively affect the printer performance and the part performance as the part is still printing, which could lead to cracking, warping, things like that. You really want a stable, warm environment for your parts to print in, especially when you're printing ABS and ASA. So if your printer doesn't already come with a kind of built-in enclosure in the printer's design, it's really important to put your printers in some type of enclosure, whether you build a custom one like this or you just buy a cheap one off Amazon. So I've got this. I had 2 printers in here. It worked great for a few years, but now I'm building a whole new one over here. It's hard to see, but it's basically a wireframe rack. So I'll have 2 printers on the bottom there and 2 printers on the top, and I'm going to be fully enclosing that and then putting some acrylic kind of panels on the front, just like here, so you can see in to see how the printers are doing without actually having to open the door to the printers. It's kind of like baking. The less times you have to open the oven door, the better it is your cake or bread or whatever it is you're baking is going to do. Currently, I have a different type of material in here that's PLA. That's one of the most basic entry-level materials. It's horrible for heat performance, so that's not going to do for car parts. So I'm going to have to change that material out, and then like I said, I'm going to change the nozzle out for the 0.6 millimeter nozzle, which will allow us to print larger parts a lot faster. So I've got my roll of ASA material here. It's in its sealed bag. It's always important to keep your material dry. That's a whole topic for another video. But I'm going to open this up and get the material loaded and the nozzle switched over as well, and then we'll get to printing our test and calibration part. So first step, what we're going to want to do, flick the printer on, get it up to temperature, and remove this material. When you change the nozzle, you can't have any material loaded, or else it's just going to make your nozzle change a lot harder and more difficult. So let's get the material out, or turn the printer on, heat up the printer, get the material out, and then we'll change the nozzle. Alright, printer's up to temp. Let's get this material out. Alright, next step is to get the nozzle off so that we can replace it with the larger one. Got the old nozzle out. It's always important to clean off the area before you install your new nozzle, so I'm going to be using this gentle brass wire brush here to clean off the heat block so that we've got nice clean surface for our new nozzle to thread into. After several hours or days or weeks of printing, a lot of material kind of builds up there, especially if you have any extrusion issues. So I was having some burnt material that kind of got stuck up in there, and it's not going to bode well for printing good quality parts. So make sure your printers are also always nice and clean and ready to go. So I got the new nozzle. Let's go ahead and get that all installed up in the heat block. Gotta do that quickly before the nozzle heats up, and then I'll use the socket to get it plumbed up the rest of the way. Then it also helps to use a kind of set of pliers to grip your heat block so it doesn't rotate when you're tightening down your new nozzle. Alright, new nozzle is installed, nice and clean up in there. So this is the area I was talking about that had a bunch of gunk built up, so that's where I just brushed off with the brass wire brush. Unfortunately, my silicone heat sock, which is just kind of like a heat barrier, ripped, so I'm going to have to get a new one of those. But this is usually what goes over your heater block and nozzle to protect your part, and just to keep localized heating down to a minimum. But after a while, these get pretty brittle from the heat cycling, so this one unfortunately tore right here, but for now we'll do just fine without it. Okay, so now that we got our new nozzle installed, let's go ahead and get this material off the spool and get our new material put up there and loaded into the printer. It's always satisfying puncturing these vacuum sealed bags that they come in. Never gets old. And then you just kind of rip it open. Although I think I probably could have saved this because this was a resealable bag, but I've got a dry container. Alright, here's the material we'll be printing with. It is Polymaker's Black Polylite ASA. Not sponsored by them or anything, but hey, Polymaker, if you see this video and you want to sponsor me, let me know. But I just have had good success with this filament in the past. I did buy it myself off Amazon. It got here very quickly, which is another great selling point for this filament. And it just has great reviews. It's really good quality filament. They have nice material specs posted on their website, and you can see the basic settings right here to print with, although we'll be definitely fine-tuning those settings a bit more based on our printing setup. Alright, so let's go ahead and get this PLA out of here. Won't be needing that where we're going. And get this ASA set up. So before I actually load this filament all the way to the nozzle, I do need to bump up the temperature to the higher temperature for the ASA material. The PLA that was loaded in, or that I unloaded, was at 215°C. You don't want to overcook this because then you risk burning it in the nozzle and creating clogs, even though we just replaced our nozzle. So I need to bump this temperature up to the proper print temperature for ASA, or even extruding temperature, so we can prime the nozzle, which is about 240°C. So it's kind of hard to tell, but right here is white. So even though we replaced the nozzle, there was still some residual PLA in the heating block probably before the nozzle, so we need to prime all that out, and it's slowly transitioning from white to gray and then eventually to the black of the new ASA filament. So what I'm going to do to purge is actually just run the extruder, which is kind of counterintuitive, but in my printer here it says move axis, and then you're going to go here, and then this is just going to actually run the extruder motor up here to run filament down into the nozzle. So let's click the move 10mm increments, and then we're gonna run this for a little while to give a good solid purge on the nozzle. Now, as the nozzle's purging, I just wanted to go over another quick tidbit of information, which is really more safety related. Now, earlier I did talk about why it's important to put your printers in an enclosure anytime you're printing ABS or ASA, but it's also important to put your printers in an enclosure that's also ventilated when you're printing ABS and ASA, or really any polymer with styrene in its name. So ABS, ASA, polystyrene, or in 3D printing you usually see high impact polystyrene or HIPS. Anytime you're printing with that, you're going to want to have a well ventilated printing setup. I would not recommend having your printer in your bedroom or anywhere in close proximity where you spend a lot of time. I think it's VOCs or particulates that get emitted while this material is melting is not great to breathe. Now, there's plenty of other videos on YouTube that go into the details of what type of emissions you see from different 3D printing materials. I'm not intending to do that in this video or any future videos, so go check those out. But that's why I have this printer in an enclosure, or in the new one that I'm also building too. Can't see it down here, but there's also a ventilation fan that vents to the outside. So it pulls air in from down at the bottom here and goes through a conduit or dryer vent tubing and vents it to outside the garage here. And I just have the front off of the printer cabinet while I'm just working on the printer. But once I'm done here and the part's actually printing and running through a lot of material, this is going to be fully closed up. Okay, so now I'm heating up the bed to the printer to about 70°, and this is just my initial settings. I'm going to have to probably fine-tune these and see how this first initial print goes, but I'll be doing that off camera after this video concludes. So the next step is, let's hop over to my computer and get the printer file set up, or build file set up, so we can run our calibration print job. I guess one of the other things I should mention real quick was it's important to have a clean print bed surface. And again, I'm going over a lot of basics of 3D printing, so just for those that don't have any previous experience or background with it, but I commonly use a glue stick for good adhesion to the print bed. That's another thing, but it leaves a lot of residual after several prints. So what I've done here is sprayed a little bit of isopropyl alcohol, let it sit, and then I'm using a little metal spatula to actually run and pull that residual glue stick material off, because that's just a PVA material that comes off nicely and dissolves with alcohol or even water too. Okay, so now over onto my printer here. This is the software that I use to set up builds and parts on my 3D printers. It's a common open source free software called Ultimaker Cura. And what I've got loaded onto the print bed is one of the most common kind of test, calibration, and stress test parts. It's called a 3D Benchy. It's a little kind of like toy kind of figurine tugboat thing. It looks simple in nature, but all of the features on the tugboat, like the overhangs and the little chimney and the contours of the bow of the boat and different things, actually are a way to show if your printer is performing well in different areas, and it'll kind of help with some experience you to learn how to fine-tune different parts of your printer. So I'm going to go ahead and get this sliced up, get the settings all set and correct for the ASA material, load it up on the SD card, and then we're going to get this thing printing. Alright, let's go ahead and pop in the SD card with our loaded build file, and we'll get to printing here. Alright, printer started, and now it's running a purge line, and then we're going to start printing the part. Alright, so this is going to take about 2 hours to print. I'm probably going to go to sleep, and we'll check in on this thing in the morning and see how it printed, and kind of wrap up the video and talk about what's coming next. But first, got to get the doors put back up on the printing cabinet. And then what I was talking about before, here's my ventilation fan. So there's basically a PC fan right here to a custom 3D printed duct that I built here. Goes to some dryer vent tube, and then down and out a kind of vent from my garage here to the outside. So I'm going to flip this guy on so we can cycle some air out of the enclosure. Alrighty everyone, so the print has finished, and I'd say overall it was a relative success. I'll zoom in the camera here and we can go over some of the fine details and some of the things I'll be tuning, but I'll do that off camera and I'll be wrapping up the video here shortly. So again, this is a 3D benchy. It's a little basically tugboat, and it's called a benchy because it's kind of like a bench test for your 3D printer. All these different features on here, from the arch to the kind of cabin area to the chimney or smokestack to the holes here, the curvature on the bow, which we had a little bit of issues with, the text on the bottom, the feature, the little flag stand on the back here, the stepped roof here. So all of those are different ways to help dial in different settings for your printer and material. So what you can see here on the front here is we had a little bit of issue with the basically bow of the ship, and we just had a little bit of issues with cooling of the material from each layer and the overhangs, because as you can see, this is all self-supporting. This is all printed with no supports, so this entire front bow here is all self-supporting at like about a 45-degree angle. So I think this material wasn't cooling fast enough, so it was kind of falling or lifting up a little bit. So I'm going to increase the part cooling fan a little bit on the printer, and I'll reprint it here and see how it turns out. So before I end the video, guys, I just want to kind of show you my current 3D printing enclosure and the one I'm also building right now. So this is the one I built about 2 years ago. I actually did a whole video on it on my channel. Overall, I'm really happy with this enclosure. There's just a few things I'm not the biggest fan of about it. One, it's not on casters, it's just straight sitting right on the ground. So if I wanted to ever move this thing to rearrange the garage or clean, it's really difficult to do that because this thing does weigh a decent amount with all the wood and printers in it and everything like that. The second is, I'm not too stoked on how this kind of industrial shelving was constructed. There's no cross braces for the shelves. There's only a long brace that goes this way, a metal brace, but side to side it's all supported just by the MDF, and the shelves actually sag from just the weight of 2 printers. So I'm not too stoked on that. But overall, and the sliding design for the acrylic panels or plexiglass panels, it works just fine, but I'd honestly rather have hinged doors. I think it's just easier to open it and work on, you know, both printers at the same time. So I'm going to take a lot of the things that I incorporated in this, like the lights. I'm really a big fan of the lights in this, and incorporate that into my new enclosure. And on top of the fact that this enclosure was built when I only had 2 printers, now I have 4. So I've got to build an enclosure that also accounts for 2 more printers. But I also really liked, I incorporated this little tool holder on the side here, so I'll definitely be bringing that over to my new one as well. So that's my current setup. I'm going to quickly show you guys the one I'm building right now. So pardon the slight little mess, I'm kind of using it as an actual shelf for the time being because there's a lot of things going on in the garage here, but this is going to be the new 3D printing enclosure. One, it's a little bit taller than the old one here. It's about, I think, 6 inches taller than that one. It's built from your standard kind of wireframe shelving, although this is a very specialty size that I had to order from a restaurant supply store, and I'll go into this in a lot more detail. I'm doing a whole video specifically on building this enclosure. But the trick that I needed for the 2 larger CR10 printers on the top, because they're bed slinger printers, you need at least a 30-inch depth, which I didn't have for that one, so I had to build an extension off the back of the shelving unit. So this, I can just box in the shelving because it's the minimum depth that I need of 30 inches, and we're good to go. And then you can see I've got a whole nother shelf on the bottom there for my 2 smaller printers. But I do like this one because the 2 larger printers, which I imagine I'll be using most of the time, are kind of more at a working level. This is kind of right at my, you know, mid-chest level, so it's going to be a lot easier to work on these. So over the next few weeks here, I'll be building this out, putting some plywood shelving to seal in the shelves, and then also putting some plywood to seal in the sides, and then building some acrylic or plexiglass clear doors for the front, adding lighting and a bunch of other kit and caboodle that will be well discussed and talked about in the video of actually building this thing out. But like I said earlier, having a proper enclosure set up to get a nice stable printing environment is a huge key to printing successfully, especially with printing somewhat specialized materials that isn't just basic PLA. So based on the settings that I'm fine-tuning with this 3D Benchy calibration print, I will be incorporating those settings with the new ASA material that I'm using into those inner fender spacer kits for the C5 Corvette, and I'll have those back online on my Etsy store shortly, now that I also got those back ordered parts for my printers as well, and I'm getting the material settings all fine-tuned and everything like that. So stay tuned for that. If you've been on the lookout for those spacer kits, they will be back on my Etsy store momentarily. So guys, that's going to do it for this video. I apologize if this one was a little bit into the weeds as far as some of the details of 3D printing, but that is my goal here moving forward, is to incorporate more details on different things about 3D printing, specifically for car parts and things like that. So I will be diving into more detail on 3D printing. So if you're here for the Corvette content will still maintain true and be producing videos on that. I've got a lot of cool videos to come on the car itself and modifications I'm doing, but I'm also going to now be doing some 3D printing videos, and then also the lovely videos of where 3D printing and the car come together as one here. So I'm really excited for the year to come, and I hope you guys are too, to see all the fun projects and parts I'll be building for not only this car but other things around the house and other kind of fun projects that I have in mind. So if you guys have any comments or questions or ideas for future videos, I'm always open to hearing your ideas. Please feel free to leave a comment below or leave your question below, and I'll be happy to answer it. So thank you all so much for watching. If you haven't already, subscribe for a lot more videos to come in 2024. And other than that, guys, I will see you in the next one.